All right, we just learned about our EIGRP hello packet and the main role of the update data packet, including what content is contained in our neighbor version. Next, we will continue. The first thing we need to understand next is about our EIGRP. Our EIGRP effects. The conditions for establishing a good EIGRP neighbor relationship. Conditions for establishing a neighbor relationship. Okay, we are now going to establish a good EIGRP neighbor relationship. For example, R1 and our R2. So if we want to establish a neighbor relationship between us, what points do we need to pay attention to? How can we establish a normal EIGRP neighbor relationship? What content will affect the establishment of our neighbor relationship? The first point is what EIGRP's AS number are. The AS numbers must be consistent to establish an EIGRP neighbor relationship. The specific reason was mentioned in the last lesson. For example, R1, I live in AS90. I belong to such a group of AS90, such a router in a group of devices. And R2, we belong to AS, for example, AS100. You live in the AS90 neighborhood. I live in the 100 AS neighborhood. Both of us are not in the same neighborhood. We don't live in the same building. Can we become neighbors? Isn't it impossible, right? What is a neighbor? Neighbors are adjacent to each other. There are no rooms, right? Even if there are 2 rooms in between, it's okay. But it's too much. If you separate a neighborhood, how can you become a neighbor? Isn't it necessary? So we both must belong to the same AS. For example, our 2 routers. We both belong to the same AS90. To establish a neighbor relationship, if the AS numbers are different, then it won't work. For example, if I do this on R2, on R1 I change it, remove router EIGRP 90. Now all my EIGRP on R1 is deleted. I deleted all the EIGRP configurations. On R1, show IP interface brief. Why is there no leak information? Okay, let's do this. Now I am going to recreate. I create an EIGRP process. So the AS I belong to is 100. So now I network 172.16.12.1. 0.0.0.0, precisely declare my 0. 0 interface running. EIGRP, put into EIGRP 100. Our R1 routers 0 interface. Believe that it belongs to AS100. Go ahead and our October 1st 10. 1.0.0.0. We also believe that we belong to AS100. So 2 routers. We are now successfully running our EIGRP interface brief. So let's look at this data packet. In the data packet, R1 is sending hello packets to R2. R2 is sending hello packets to R1. But nothing happened between them. R2 says I belong to AS90. What does R1 say? R1 says I belong to AS100. We are not in the same neighborhood, not in the same building. How to become a neighbor relationship. So at this time, they don't recognize each other. I don't know you, you don't know me. So the neighbor relationship can't be established, so the AS number must be the same. To establish a neighbor relationship, this is the first point. So the second point, this first point. Actually, few people will make mistakes, so there won't be any big problems. So the second point, so the K value must be the same. Take the K value. So what is the K value? What students need to pay attention to is, we mentioned it in our NA, each of our routing entries. What will it have administrative distance and metric value? For instance, on R2. Then every type of routing entry, whether it's EIGRP routing, whether it's direct routing, whether it's host routing, each will have corresponding administrative distance and metric value. Of course, some students might not have finished the NA course. I will supplement here. Then the router. In the routing table, what should be exchanged is the most optimal routing entry in the router. Only the most optimal routing entries will be stored. How to judge the quality of a routing entry. Then, when the same prefix appears, when different routing entries with the same mask appear. Then we will compare. We'll compare the administrative distance of the routing entry and metric value. Then what are they? The smallest is the most preferred. The smallest is the most preferred. Also the most optimal. The most optimal, then only the most optimal routing entries can be submitted to the routing table. Then only the smallest administrative distance and the smallest metric routing entry. First, compare the administrative distance, then compare the metric value. Then the smallest will be able to be submitted to the routing table. Then what is the administrative distance? You can understand it as the priority of the routing protocol. Then the smaller the priority, then each different routing protocol. All have their corresponding priorities. For example, let's take an example. We are on R1 and R2. Let's look at this direct route show, IP route 172.16.12.0-24. Sorry, can't write //25.25.25.0. Look at this direct route. It's a direct connection. The administrative distance is 0. The metric value is 0. So we found out, when we need to compare routing entries, the smallest administrative distance is compared first. The smallest is the most preferred. Then, the administrative distance of the direct route is the smallest value of 0. Negative numbers cannot exist. Is the smallest value 0? Then, so its priority. Basically, students in the network, in the router's data packet. The smallest priority is always the direct route. What else? Host route. For instance, this host route 172.16.12.1.25.25.25.252. Sorry, I made a mistake. Point 2. What is the administrative distance of the host route? Administrative distance 0. Metric is only 0, isn't it, students? Then list it out. Okay, because students might not have finished NA. Then protocol type, administrative distance, then metric value. And the metric value, make a table for him. Then as a direct route, administrative distance 0, metric value 0, then host route, administrative distance 0, metric value 0. Then, for instance, static route. We randomly write an IP route 8.8.8.0 25.25.25.0, for instance. G01, randomly. Write a static route. Show IP route 8.8.8.0 25.25.25.0 static route. The administrative distance is 1, static route, default. Administrative distance 1. The metric value is 0. Then we found out, suppose at this moment, we have such a direct route in our network. About the direct route of 172.16.12.0-24. I do this. I write a same prefix 172.16.12.0. Same mask 25.25.25.0. Out of the interface. For example, it is 0. 0 I write like this. I write to 0. 1. Such a different next hop. Direct route. No, such a static route. Then the question comes, classmates, now for a router. The left side is a direct route, 12.0. 25.25.25.0. We write a static route on the right, 172.16.12.0. 25.25.25.0, it's 0. 1, this side is 0. 0, same prefix, same mask, different route entries. Then the router is simple, our router in the future. But it has to be sent according to the routing table. The routing table is equivalent to our router's map. How can you do it if your map is not accurate? So, in the routing table, it will definitely put the best route I will compare, right? Only one can be selected from the two. A unique and best route. Put it in the routing table. Compare the associated distance. The associated distance of the direct route is 0. The associated distance of the static route is 1. What are they all? The smallest priority. So, if there are two same route entries, one is static, one direct route. A static route, the one with the smaller associated distance is the best. So the direct route will be submitted to the routing table. In the routing table of R2, Even if we write such a static route, it's useless. It won't take effect. Only one will be put in, direct route. Static route will not take effect because its associated distance is larger. So if our direct route is gone, if this direct route is gone, then our static route can take effect. Classmates, for example, like this show IP route. Then our static route takes effect. It floated up. So if our direct route comes back, no shutdown. There is a direct route with an associated distance of 0. Then only this will be stored in the routing table. Direct route. Because for the router, the routing table is its map. Its map must be accurate. Only one best route will be put in, compare the associated distance of the route entry, compare its metric value. So the associated distance we talked about, it's like the priority of each of our routing protocols. Each routing protocol has its own priority. We, NA, talked about our RIP protocol. Associated distance, 120. The metric value is calculated based on the number of hops. Then EIGRP, okay, we just saw the associated distance is actually, in terms of metric value, we'll talk about it later, classmates. We just mentioned actually the router. The routes we submit to the routing table must be the best routes. Compare associated distance, compare metric value. To choose the best to choose. Then the metric value. What is it calculating? Administrative distance is used to distinguish our routing protocols. And the metric value, classmates, is like different administrative distances is our way to different destinations. When we forward according to the routing table, this administrative distance is our distinction between different means of transportation. So every mode of transportation has its own administrative distance. For example, bicycles and motorcycles, and our airplanes. Right, high-speed trains. So every different protocol, every different mode of transportation has its own priority. And the metric is our mode of transportation, your cost, how much money you need to spend. Understand, students, the metric is similar to the cost value. It's the cost of using the mode of transportation. When you visit the destination address, how much you need to pay. This is the metric. So similarly, the less money you spend, the higher the priority. First, compare the administrative distance. First, compare the modes of transportation. Choose a better mode of transportation. Then, if the modes of transportation are the same. I see who spends less money has higher priority. Therefore, students, the metric is also our criterion for a routing entry. One of the important conditions for excellence. So for EIGRP, this metric, you see how much money is spent. How should it be calculated? We are talking about K values, EIGRP's metric. This metric value, I want to go to this destination. You see R2, I am going to access 10.10.3.0. How much should I pay? To be able to access the other party, we choose the EIGRP dynamic routing protocol, this routing entry. Then how much to pay? To access 10.10.3.3. This is our criterion for routing entries. So how to calculate the EIGRP metric through K values We go to show IP protocol, our EIGRP's K values. The default is 10.100. Of course, due to the current time constraint, we first finish the process of establishing EIGRP neighbors. Finish the conditions that affect it. After finishing this, we will talk about how should we use K values to calculate the cost of our routing entries. The metric value, students. Let's first understand K values. K values must be exactly the same. We can establish a EIGRP neighbor relationship. So R2 is 10. 10.0 R3 show IP protocol. Let's see what IPv4 protocols are running on our router. So our metric, our K value is 10, 10.0. Both are the same. If they are the same, they can be used to calculate our K values are the same. We can form an EIGRP neighbor relationship, but you see in our hello packet, so the K values are also sent out, but let's keep K6 a secret for now. We'll think about what K6 is used for later. Students, so the hello packet contains the K values of our two routers. They must be exactly the same. To be able to establish an EIGRP neighbor relationship, you can understand K values as the values of our two routers. So what is your calculation method for routing entries? So what is my calculation method for routing entries? We have the same values. You can't say you think $100 is not money. I think every dollar is money. If two people have different concepts, how can you possibly establish a neighbor relationship? Two routers to become EIGRP neighbors must have the same K values. If they are not the same, they cannot become neighbors. So the K value mainly involves when we calculate EIGRP routing entries. If they are not the same, they cannot become neighbors. So the K value mainly involves when we calculate EIGRP routing entries. So there are 5 K values: K1, K2, K3, K4, K5, 5K values from K1 to K5 correspond to the EIGRP routing calculation, considering link state as well as the link's parameters. What do they correspond to? From K1 to K5 corresponds to bandwidth, delay, reliability, load, MTU, when EIGRP calculates the routing entries. This metric value, when we go to the destination network, how much we need to pay, we will base it on the relationship parameters of the link to the destination network, bandwidth, delay, reliability, load, MTU to calculate this metric value. Then there is a K6, which we just mentioned. It corresponds to our router. K6 corresponds to what Cisco designed, corresponds to the power consumed in the link electricity. Because EIGRP wants to say we should be able to automatically calculate an optimal routing entry, how we should go to the destination. Therefore, we need to consider how I take the bus, what route to take, how much to pay, and whether there will be traffic jams on the way. We will constantly consider the state of this link when we access the destination address, bandwidth, delay, reliability, load, MTU. And students. The Cisco designers at the time were also thinking, if I could also consider when we access the destination address, the power consumed by the link interface. What is it? The energy consumed by the interface. However, we later found out, you see, we actually only use K1 to K5. The scientists at the time thought, let's bring out this K6 to correspond to the power consumed by our device interface, the energy and resources consumed, and found that this idea was a bit fanciful and not usable. So K6 did not participate in our EIGRP regarding the calculation of the metric. Of course, we can change it, for example, R1 router, EIGRP 90. We let R1 establish a neighbor with R2 again. Point 12.10, point 00.010.10.1.10.0.0.0. We do this. If we modify the router's K values, then now R1's K value is 10100. Of course, we haven't talked about how to calculate the metric value using K values. We'll keep it a mystery. So for R1, we say if R1's K value, for example, the key is EIGRP. The command seems a bit outdated. Haven't used it in a long time. Sorry, let me find the metric. Found it metric. Wait, modify our EIGRP K values. And when modifying, there is also an additional parameter called TOS students. When we modify our router's K values, there is also an additional field called the TOS field. So TOS, we actually mentioned in NA's IPv4. We talked about this thing in the IPv4 header, called TOS field. So regarding TOS, actually, in NA's IPv4, we have already mentioned it, this thing in the IPv4 header. There is such a TOS field, so this TOS is called type of service. So what does it record? It's called the type of service we have mentioned in the future. We can use QoS, that is, quality of service. So for our different types of data traffic, for our TOS field, the priority of your data packet to be changed, to do things like speed limiting, to guarantee bandwidth, to do these operations, students. Then in our EIGRP, the designers of our EIGRP at the time, they thought, I want to make our EIGRP able to design automatically. Change the priority of our EIGRP data packets. Let our EIGRP, the priority can be automatically variable. For example, when congestion occurs, our EIGRP's hello packets. The priority of these packets is relatively high, they can't be discarded, but it was later found it conflicts with our subsequent QoS. We can't do it this way, so it was found. Although we can set the priority of EIGRP, we can choose from 0 to 8, but it added 1. You can only use 0, you can't change it, students, so it's quite embarrassing. The scientists thought at the time, we can change the priority of EIGRP packets. Let us not be discarded when congestion occurs. Let us have higher forwarding efficiency. But it was found to be difficult to implement later, just like our K6. Like K6 is difficult to implement, just a fanciful idea can't be implemented. So there's no choice but to abandon it. Although you can change it, can only be set to 0. Of course, you can set it to 8. It won't give an error, it won't give an error. However, it will secretly change it to 0. For you, even if you set it to 8, it's useless. It will still change it to 0. Let's not rush later. You see the value of K1, K1, K2, K3, K4, K5, for example, K1, 1, 1, K2, K3, K4, K5. There is also a K6 that we are not allowed to set. The default is 0 because they thought K6 could be used in the future. Can be calculated. The power consumption we use, of course, it should have been abandoned. Enter, we have modified the K value of R, 1. Then show IP protocols. You see, our K value is 1111111. Then you see what happens when the K value is inconsistent. It says, our neighbor is down. The relationship with the neighbor has changed. Then, what? The neighbor is down. K value is inconsistent. Mismatch. What are the two of us? I calculate bandwidth. I calculate metric values. Calculate the cost of routing entries. I use a set of values. I think $1 is money. You think our $100, he thinks $100 is money. It's just a disagreement between the two. I give you inconsistent opinions. Sorry, we can't become EIGRP neighbors, students. It won't work if it's inconsistent. Then show run section BI router EIGRP. Let's look at the EIGRP configuration. You see, we set it to 8. How much has it changed to 0? Although it says you can change the data packet priority, but it doesn't allow you to change, it's useless. That is to say, it's an invalid operation, or it can only support 0. If the K value is inconsistent, EIGRP neighbors cannot be established, because our two opinions do not agree. Cannot become EIGRP neighbor relationship. This is the second point. The K value must be consistent. The first one is the AS number. The second one is the K value. Then the third one, it's also quite important, called source detection passed. Source detection passed. Can EIGRP establish neighbors? We must pass a source detection. So what is source detection, for example? R1. When I receive the other party's EIGRP hello packet, I can see who is sending the hello packet. For example, R1. I know it's 172.16.12.2. Who sent me the hello packet for EIGRP to establish neighbors? There is a very important point, source detection. For the hello packet sent by the other party, I will look at the source IP address of your hello packet. So this source IP address on my router, is it reachable? Students must pay attention. Received the EIGRP hello packet. We'll check the source IPv4 address of the hello packet. In the routing table of this router, is it a direct link and reachable? If it is not reachable, we will find it's not my directly connected router. It's not my direct link router. It's not my what? In a building only separated by a room, such a neighbor. We said that routers can isolate broadcast and multicast, so the hello packet from R1 to R2 cannot send to R3. Because our router can isolate each network, only between routers on a direct link, we can establish a neighbor relationship. So students, once our router received the EIGRP hello packet, we will check the source address of the hello packet. What will you see? The source address of your sent hello packet. Is it a device on my router's direct link? Can it be accessed? Can it be reached? If it is not reachable, I won't build neighbors with him. How about it? You are not my neighbor. What are you building with me? You and I are separated by mountains and seas. How can I become a neighbor with you? What should we at least do between us? It must be directly reachable to become a neighbor relationship. If it is not reachable, it won't work. For example, let's change a style. I do this. Now I change R1 a bit. I am 172.16.23.1-24. I belong to the 172.16.23.0-24 network segment. So we and the zero interface of R2. It's not a network segment anymore. So at this time, can we two establish a neighbor relationship? Do an experiment. So we log into R1. I do this, zero interface IP address, 172.16.23.1. So I let it run, our EIGRP, okay. Can a neighbor relationship be established? He said it's not possible. He said not command subnet. We are not in the same subnet. The other party received. When we receive the hello from the other party, we find the other party's interface address and mine are not in the same network segment. Our two direct connections are not mutually accessible. How can you become my neighbor? Source check failed. Do you understand, students? Source check failed. This is definitely not possible. It's not possible. It's no good. It's not possible. So this is source check. Even if our two masks are not the same, it's possible. For example, we do this on our zero interface IP address, 172.16.12.125.25.0.0. So what are we? Belong to the 172.16.0.0, 16 network segment. Then R2 next door, that is 172.16.12.2-24. Can also become a neighbor relationship. You see it. As long as what? As long as we receive the hello packet. The source address of this hello packet on my device. There is a directly connected route, reachable, can access my direct link. The hello packet sent by the neighbor router. To me, then we can establish EIGRP neighbor relationship. This is source check passed. Okay, students, this source check. Any questions, students? Any questions about source check? If there are no questions, let's talk about next. We will make a one-sided neighbor. Let's create a one-sided neighbor. We can go. Break a language detection routine. Can break a language detection routine through a method. Like this, we change the address, 0.0 interface IP address, 172.16.23.1225.25.25.0. Let's make a language detection failure. Source, check failed, students about to jump logo. Okay, let's do this. Now R1, we send EIGRP. Hello packet. Our source address is 172.16.23.123.1. Send EIGRP hello packet. R2 finds that your source address is not in the same network segment as me. I won't receive your hello packet. I don't consider you my EIGRP neighbor. R2 will not consider R1 as my EIGRP neighbor. As for R1 also, not as for R1. What have we received now? R2, the EIGRP hello packet he sent. The source address is 172.16.23.2 sent EIGRP hello packet. For R1, I see you are 12.2, sent hello packet. You are not on a direct line with me. I can't access, so I won't receive your hello packet either. So neither can establish EIGRP neighbor relationship. Next, let's make a one-sided neighbor. How to do on our IPv4 router. we can configure an auxiliary address, auxiliary address, auxiliary address, students. Its function is very simple, auxiliary function. The auxiliary address configured on this interface. It can be accessed, but it cannot actively access students we can on a router interface. Configure an auxiliary IPv4 address. It can only serve as an auxiliary function. It can be accessed by others, but it cannot actively send out, cannot actively send messages. As long as the router wants to actively send messages, it will definitely use its primary IPv4 address. It configures such an IP address, 23.1. Then our interface's auxiliary address. It can only be accessed by others. Let's make a unilateral neighbor on the 0 interface of R1. We configure an address 172.16, for example, 0.12.2502.5.25.25.0. We add a parameter. Secondary auxiliary address, enter. So at this moment on R1's interface, 00 interface, we have configured two addresses. One is the primary address. If once the router, R1, wants to actively send messages, when sending messages with 0, we'll definitely use the primary address as the source, use 23.1 as the source. But we also have an auxiliary address on our interface. This auxiliary address will also generate direct routes of the 172.16.12.0 network segment. Direct route. It can be accessed by others. Students are here. Now, after we have configured an auxiliary address on R1 has an auxiliary address, 172.16.12.250-24. A is an auxiliary address on our R1's 0 interface. It can be accessed, but cannot actively access messages, access others. So now for R1, the EIGRP, hello packet. I send with the primary address as the source. As long as it is actively sending messages, all are sent with the primary address as the source 172.16.23.1. Use the primary address as the source. The EIGRP hello packet sent out is from R1. Then this data packet arrives at R2, R1 sees. You are not in the same network segment as me. Not a direct connection router, not directly connected, source check failed. I can't access you. R2 will not receive the hello packet sent by R1. R2 does not consider R1 as my EIGRP neighbor relationship. You see here at R2, he will scold people. You are not my EIGRP neighbor relationship. You are not in the same network segment as me. Not a router directly connected to me. Not a neighbor. R2 will not receive R1's hello packet. But on the contrary, students, R2 sends the hello packet with our primary address as the source. 172.16.12.2 sent hello packet on R1 now has such an auxiliary address on the structure. Although it cannot actively send messages, but this auxiliary address will also generate the direct route corresponding to the interface. In the routing table, it can be accessed for R1. I received a hello packet 172.16.12.2 for R1. It is a device on my direct route. It is a device on my direct link. Send me the hello packet. It can be accessed R1. We can receive the hello packet sent by our students R1 received. The problem comes. The hello packet R1 sent to R2 does not receive. The hello packet R2 sent to R1 received. R1 thinks R2 is my neighbor. R2, I don't think R1 is my neighbor. A unilateral neighbor situation has occurred. Students, this is a unilateral neighbor. We look at R1's in the EIGRP neighbor mark. You see, although my address is 172.16.23.1, even though my address is 172.16.23.1. But because the language detection is passed, I also think 172.16.12.2 is my neighbor. The same is true for R2, show IP, EIGRP, neighbor. What am I doing now? I only think R3 is my neighbor. You R1 and I are not in the same network segment. I won't receive your hello packet. A one-sided neighbor situation has occurred. So at this time, teacher, why do you specifically create a one-sided neighbor? Our purpose is very simple. One is to let students understand what is source detection. The second is to let students see a phenomenon 16 times retransmission mechanism. Students, the two purposes of our experiment. The first is to let students understand what is source detection. The second is to let students know, what is the 16 times retransmission mechanism? We have mentioned before, once we have established a neighbor relationship, we will use the update packet to confirm the reliability of our link. So good students, for R1, I have now received R2's hello packet. I think R2 is my neighbor. What to do? R1 will immediately send 3 times to R2 update packet. Wait for the other party's ACK for confirmation. We use 172.16.23.1 as the source. Use the storage address as the source. Give R2 to our neighbor. Send update to the newly established neighbor. Ensure this reliability. Send to R2. So for R2, will I receive your update packet? Will R2 receive it? Students, will it be received? Let's think about whether R2 will receive it. Will it, isn't it? I am not your neighbor. You see, R2, I don't even receive your hello packet. I am not a neighbor relationship with you. You send me an update. I, R2, won't receive it. So R1, the update packet we sent to R2 will not give out ACK. Because R2, I don't think R1 is my neighbor. So for R1, I send data update and don't get a reply. Send data update and don't get a reply. Then after a period of time, if you don't receive our ACK, what do? We'll retransmit exceed RTO time. If you don't receive our ACK, we will retransmit. So at this time for R1, I will keep sending our update packets. Set the FASTQ bit to 1. The update I sent did not receive an ACK reply, set to 1. And because there is no 3 times to receive ACK, no 3 times update round trip, I'm not sure about my SRTT, I'm not sure about RTO either. According to the default value, SRTT 1, RTO 5000 milliseconds. Then send update and don't receive ACK, waiting for processing. If you don't receive ACK for more than 5000 milliseconds, retransmit once. Resend update, wait for confirmation. Then send again. We will find a phenomenon in the network. You see, R1 is always sending update to R2. If you don't receive ACK after exceeding RTO time, send it again. If you don't receive ACK after exceeding RTO time, send it again. Send. So if you don't receive ACK, keep sending. How many times to send? Send 16 times. For R1, after 16 retransmissions. If you still don't receive ACK, I will disconnect the EIGRP neighbor relationship with R2. So after disconnecting, R2 has sent another hello packet to R1. Because we mentioned the interface of R2, once EIGRP is running, it will start sending hello packets every 5 seconds. So the hello packet of R2, R1 received it again. R1 thinks R2 is my EIGRP neighbor again, and starts to establish a good relationship again, sent an update. Then after 16 retransmissions, it thinks the neighbor is unreachable again, and disconnects from the neighbor again. Then it receives a hello packet again, sees the neighbor retransmitting again. So the neighbor will keep flipping. You see, it's up again. You see what's next. Repetition limits, right? It has exceeded our number of attempts, 16 retransmissions. Then it disconnects from the neighbor. After disconnecting, it's up again. After it's up, it disconnects again. We can see this through debug, IP EIGRP, update, packet, debug, EIGRP, packet, update, packet. So R1 will keep sending update packets and wait for ACK confirmation. Then after we have sent 16 times, still not receiving the other party's ACK, We will disconnect from the neighbor and reestablish. We wait for it to establish next time. Wait for it to establish a good neighbor relationship. Next time it's down to 16. It's disconnected. Immediately received R2's hello packet. Reestablish the neighbor relationship. Send update packets. Wait for confirmation. No reply. First, retransmission second. Retransmission. It needs to retransmit 16 times. 16 update packets. Can't get confirmation. We, R1, will actively disconnect the EIGRP neighbor relationship with R2 fourth retransmission, 5th time. So this is our EIGRP's retransmission mechanism, 16 retransmissions mechanism. If we establish a good neighbor relationship, we can't get ACK for the update packets we send. Then we will resend, so if we don't receive ACK for 16 times, disconnect the relationship 8 times, 8 more times. We can't speed this up. We can only wait. Wait for a while. Wait for a while. This is our source authentication. Classmates, we created a one-sided neighbor. The purpose is simple: to let everyone know what source authentication is. Then see the phenomenon of 16 retransmissions mechanism, 12 times, almost done. Soon, finally done, 16. Okay, 16 retransmissions. Disconnect the neighbor relationship down, about to go down. It went down. Friends, this is our 16 retransmissions mechanism. So next, the third factor affecting the establishment of EIGRP neighbor conditions is our source authentication passing. It's just that we did a bit more, created a one-sided neighbor. One side thinks the source authentication passed. So created a one-sided neighbor. So now we restore it 0i, 0 IP address, 172.16.12.124. Okay, so delete the auxiliary address. Delete the auxiliary address. Okay, wait for the new neighbor to come up. We look at the fourth condition affecting the establishment of EIGRP neighbor. Unicast to unicast, multicast to multicast. So now for our EIGRP neighbor establishment process, R1 sends such a hello packet. The destination address is 224.0.0.1, 0R2, sends the EIGRP hello packet. The destination address is the EIGRP multicast address, 224.0.0.10. Once both sides run EIGRP, we will all join the multicast group. All will join 224.0.0.10. Join 224.0.0.10. So we can send receipts to the multicast group. We can also receive what others send to the multicast group. EIGRP. Hello packet. As for our EIGRP, what did we say is the best use of multicast? It's in an MA network. If we have multiple devices, we can at the fastest speed. We can have multiple devices. Establish between each pair. I can establish with 3 devices at the same time. EIGRP, neighbor relationship. Send EIGRP, hello packets to 3 people at the same time, because they will all join the multicast group. All can establish 3 neighbor relationships with each other. Because of what? Because of multicast. We can send to multiple devices at the same time. Multiple devices can receive what we send out, hello packet. Establish a neighbor relationship with me. This is us through multicast. But there might be a problem. What's the problem? In an MA network. Even though I want to establish a neighbor relationship, but this router of mine, I only want to establish with one of the routers. We establish an EIGRP neighbor relationship. I don't want to establish with them. What should I do? We can say that. So by default, EIGRP uses multicast to send data packets. Default to multicast. Send EIGRP hello packets. And multicast. Send route entry updates. Except for the 3 updates when establishing neighbors. Except for determining reliability. Reliability is when we just established neighbors. We update students. Don't forget it's sent through unicast. I send you an update. Confirm the reliability between us. 2, the reliability of the link. So this is when we establish neighbors. So when announcing routes later, what will he do? Send to multicast. You see, send to 2. 24.0.1.10. Announce out our route entries. By default, they are all sent by multicast. So when establishing neighbors, I send to multicast. So you might establish multiple neighbor relationships. So what do we want to do? If you only want to establish with one of them, a router establishes a neighbor. We can specify EIGRP unicast neighbors. Can be done through the neighbor command line. So specify the EIGRP interface. The other side only establishes EIGRP with who neighbor relationship. So if we do this in our EIGRP R1, we can knock this command line in EIGRP, knock this command line in EIGRP 90. Neighbor, I specify this router, R1 of mine. So who do I establish neighbors with? I only establish neighbors with 172.16.12.2, this one router. Need to specify the interface. So my R1, my 0 interface, I only establish with 172.16.12.2. Establish an EIGRP neighbor relationship. Go ahead. So at this time, you'll find immediately our R1 and R2 neighbor relationship will be down. Can't get up. Why, students? Please note, if you use the neighbor command line, specified an interface of EIGRP, only establish an EIGRP neighbor relationship with a certain address. Only with a certain address, establish EIGRP neighbor relationship. Then this interface will no longer send EIGRP transmission and reception any EIGRP multicast packets, including hello update and our subsequent query. We haven't talked about query yet. No rush, let it be. As long as we specify the EIGRP unicast neighbor, look at R1 here once it is specified. R1's hello packet. Look at our later R1. When sending hello packets, it will not use the default multicast transmission, but I will send it individually to 172.16.12.2. I will send you a unicast EIGRP hello packet, and this port of mine I will not send multicast hello packets, multicast EIGRP packets. Do not send any EIGRP multicast packets, and it will not receive any EIGRP multicast packets. Look now, even though R2, we send hello packets through multicast, so can R1 receive it? It can receive, but I don't want it. Why, students? What is this equivalent to? Let me give you an example. It's like a central air conditioner. Central air conditioning. It's a phenomenon in modern society that is, I'm only good to you, but your love now is universal. It's given to everyone. So I don't want it. Do you understand what I mean? So I only hope you take special care of me. Only focus on me. I send you messages individually. So I also hope you reply to me individually. Between us, two are you pay attention to me, I pay attention to you. So I don't want you to do what you send this universal love to everyone. I also hope you can take special care of me. This is what our R2 does. Now R2 still sends EIGRP hello packets in multicast mode. Although its address is also ours, 172.16.12.2. Although the source address of R2's hello packet is also the neighbor address. We specified on R1 is the neighbor address. We specified 172.16.12.2. But you are not taking special care of me, sending messages to me individually. You send it to everyone. It's not a special care for me. I'm sorry, I don't want it, understand. Once we specify a unicast neighbor, our router, this EIGRP interface, it can only establish relationships through unicast, any EIGRP multicast packets. It won't send or receive only messages sent to us individually. Can we establish a good neighbor relationship? Now, a problem arises. Students, look at R2, show IP EIGRP there. Look, our neighbor hasn't come up yet. Because what is our R2 doing now? I think I should establish neighbors through multicast. But you are telling me through unicast can't do this. So I'm not ready yet. I'm not thinking about dating yet. You confess to me individually. Then I can't accept it, so I go to take care of you. Not taking special care of him alone. Not special care. He will not accept, is not particularly cared for, and it will not be accepted. It's quite awkward. So what do we mean by unicast to unicast, multicast to multicast? Once we set the neighbor address, then this interface can only be established through either establish a neighbor through unicast or establish a neighbor through multicast. You can only choose one of the two. So now, if we want R1 and R2 to establish a neighbor relationship, we need to let R2 also send messages to R1 in a unicast way. I pay special attention to you. What are we doing between us? You are the only one in my eyes. It's that simple and crude. Students, for example, here at R2, router EIGRP 90. Then me, my zero interface. I will also only pay attention to you. You are the only one in my eyes. Only the messages we send to each other. This unicast, hello packet, R1 sends a hello packet to R2 alone. R2 sends a hello packet to R1 alone. They can only receive it, only then can they pick it up. This is unicast to unicast, multicast to multicast. So in an MA network, we can use this scheme. Only let our specific two devices establish a good neighbor relationship. Of course, you can have multiple, for example, neighbor 172.16.12.3 P0-0. You can point to multiple my interface. Anyway, as long as the interface is specified. This interface, I can only establish neighbors through unicast students. This is our EIGRP's unicast to unicast, multicast to multicast command line. We can set EIGRP, can only be established in which way establish a good neighbor relationship. Limit us to only establish neighbors with whom it will be more effective in the MA network. Students, this is unicast to unicast, multicast to multicast. Write down the command line. Then router. For example, EIGRP 90. We can specify a neighbor inside, for example, ABCD, then we specify an interface, then specify interface opposite. Can only be with someone one-to-one. Establish a good EIGRP neighbor relationship. This is EIGRP's one-to-one multicast to multicast. Any questions can establish multiple. This is with us, can establish multiple. My interface opposite. It just limits our interface. I can only establish neighbors through unicast. Understand, I can only establish neighbors through unicast, cannot establish through multicast. But we can specify multiple neighbors can be specified. Just limit our interface, can only establish one. Can only establish neighbors through unicast. It didn't say to limit our interface, limit the number of neighbors like this. You may be with what may be with OSPF inside network type called P2P confused. If the network type P2P is set in OSPF, our interface. Can only establish one neighbor relationship. I establish a neighbor relationship with you one by one. This interface can only establish one neighbor relationship. Cannot be more, may be confused with it, students. We are just on the never command line. That's it. We can limit this interface of mine. So, I can only establish neighbors through unicast. So this tuple group, we still have one. The last condition that affects the establishment of neighbors is called authentication. So speaking of EIGRP authentication, we are keeping you in suspense here. Actually, it means, so on both of our routers, we set up a gate for it. So this gate has a lock. There is a lock. For example, we enabled authentication. For instance, R1, our zero interface enabled EIGRP authentication. So when the hello packet from R2 is sent over, when it is sent in, what do we need? Then this hello packet of yours must have the key to my gate. You must do what must match the key, configured on my R1 gate. This key must be consistent. To pass the authentication, I can open the door. How to open the door? Just draw it like this. Open the door and send your data packet in, so that my R1 can receive your hello packet. So, simply put, the role of authentication is simple. Ensure the security of our EIGRP neighbors. So you must pass the authentication. Your hello packet must carry a key. Carry a key and pass the authentication of my gate. For instance, iris recognition. What key recognition? Open this anti-door password. Right. After opening the door, you can send this data packet in. I can receive your hello packet. Otherwise, I won't accept it, so we are keeping you in suspense here. Our EIGRP authentication. We will put it in our subsequent EIGRP comprehensive experiment and explain it to everyone. Okay, students. So this is our EIGRP authentication. It is also one of the requirements in our EIGRP neighbor environment. One of the requirements. So there are a total of 5 conditions. Consistent AS number, consistent configuration, pass language detection, IP address, unicast to unicast, multicast to multicast, and also authentication. So, if you encounter in your future work that your neighbor relationship is not established, then you can check from this plan. We can know the conditions that affect the establishment of EIGRP. We will be able to deal with neighbors when they are not established, can be troubleshooted through these 5 plans, 5 steps to troubleshoot. Okay, students, are there any questions? Are there any questions? I'm running out of time. There's no time to talk about our metric calculation. No problem. We'll talk about metric calculation in the next class. We'll discuss it with the dual algorithm. Any questions, students? But unicast to unicast. The second line can be specified through the neighbor command line EIGRP interface. Then what does the other side mean? The other side of the interface means my interface. Connected to these devices, I only connect to the other side of my interface. For example, there might be A, there might be B, there might be C. So I only connect to my interface, to these devices in the past. Establish our EIGRP neighbor relationship. The other side refers to the devices connected to my interface. Are there any other questions? Not to establish multiple neighbors. Can only exist in MA network. This is because what your router must at least be connected to an MA network. You must connect to a network with multiple devices. Only between your devices can neighbors be established. If you say your device is opposite, there is originally only one router. Of course, you only have this one neighbor. P2P network can only specify one neighbor. It's not that you are in the MA network. You can also specify a neighbor xiaojiao. Can you translate your words again? That is, say it in more detail. Then I can understand your meaning again, because in itself, EIGRP defaults to establishing neighbors through multicast. So in a multi-access network, for example, 4 routers, we can quickly establish it through multicast. So every router builds neighbors with 3 routers. I can also choose to specify unicast. I specify a router in the network. We 2 lines are pleased with each other. I don't care about your devices. I only build neighbors with him alone. You can do this. What I mean is multiple neighbors can be established in the MA network, then P2P network, because it is just end to end and can only build one neighbor. Indeed, you only have one contact opposite you. There are only 2 routers. Of course, it is P2P's neighbor. It doesn't exist multiple people. I have another question. It's about the update you just mentioned is a network. Doesn't it send 3 consecutively? The first and the second, the first and the third, in addition to confirming reliability. And there is one more. So actually, the first one has gone back and forth. The second one has gone back and forth. It is basically determined that there is no problem with the link. When we go back and forth, the third time, 1 is to do what determine SRTT. The second one is the third packet already carries the route, already carries routing information, already passed the route. There is another one. The first 2 are sent to multicast. Then the third one is the first 2, unicast. The first 2 unicast. The first 2 unicast, the third one is multicast. The third one actually sends both unicast and multicast. You can capture packets at this place later. The third one actually sends both unicast and multicast. Unicast has also been updated. Multicast has also been updated, send 2 rounds. Any other questions? EIGRP has been made public. It has indeed been made public, but it has been made public, but it has not been fully public. I will explain this to you. It has been made public, but some key technologies have not been fully disclosed. So do you see if are there any Huawei devices using EIGRP? No, it has been made public, but it has not been fully disclosed. What is the resending of hello packets? As long as our interface runs EIGRP, it will keep sending every default time of 5 seconds. Hello packets will not stop, will keep sending. As long as our interface runs EIGRP, will not stop sending hello packets. Any other questions? EIGRP is as long as our interface is up, then running. EIGRP will keep sending, will not stop, including R1. We are sending hello packets during 16 retransmissions. We are also sending hello packets. Just hello packets and update data packets are always sent, waiting for the other party to confirm. No, now our company's network in Shanghai uses EIGRP. Pure 4-core network is purely foreign companies. Don't consider that kind of foreign companies interfacing with state-owned enterprises. Then, basically, there is EIGRP. There are projects I have encountered in Songjiang, Shanghai. Some got EIGRP otherwise. Why study for the exam? Also, take your CCIE exam. Let me show you. Anyway, this question hasn't been leaked. Just one diagram for you to look at is fine. This is what the exam is about. We need to operate on these 4 routers. Run EIGRP neighbor relationships. Run EIGRP, establish EIGRP neighbor relationships between pairs. Guess what the exam says here? R61 and R601. Establish neighbors R61 and R602. Establish neighbors R62 and R601. Establish neighbors. Establish neighbors with R602. R601 establishes neighbors with it. Establish neighbors with it. We establish EIGRP neighbor relationships between our 4 routers and pairs. And then there's a DM VPN. Here, it's also EIGRP. Let me show you. It's just that there's a line flying up here. This line flies to this, then this line flies up. Then this line flies to this. So a router, 24 and 73 routers establish DM VPN. And then also need to establish EIGRP neighbor relationships. The exam is all about IPv4's EIGRP, IPv4's EIGRP is what the exam is about. Yes, that's right, it's this area. And our DM VPN also needs to use EIGRP. Then during the exam, the data center, and HQ, they all use OSPF. OSPF is all OSPF. Then here's EIGRP. Then this side is BGP. This side, BGP runs MPS in the middle. MPS VPN, then here runs SD-WAN. The salary you need to test for is also useful. Don't think that you won't need it after you learn it. Any more questions, students? If there are no questions, we're about done for today. What time is it? It's 35. That's all for today. If you have questions, you can think about it. We'll wait a bit more. Play some music. Seems like there are no more questions. Let's go, students. See you next Monday.